everybody. This is for AP only. This is the AP Net Force practice problems, and these are the problems from HE double hockey sticks. Each one is going to have their own video because they're about 20 minutes long, and each problem will take up about a page in your notebook. So give a nice lot of room to write these. On number one, I forgot to tell you how much mass the sign has. So it's 10 kilograms. So make sure you plug that in right here, where I'll underline a 10 kilogram sign. So we're going to just have this little sign hanging down from this little wire here of 10 kilograms. And each one of these wires has a different force on it. I'm going to make this one F1. I'm going to make this one F2. And this will be F3 down here. That's force 1, 2, and 3. And then each one has a different angle. This is a 30-degree angle. That is a 60-degree angle. And then the other one hangs straight down. And don't forget that whenever you have three different forces like this that are unknowns, we're going to have to do three different problems in order to figure out what all these unknowns are. So let's just start off with one of them here. Since all these are sort of pulling up and down, I'm going to start with the y direction. And so on every one of these problems, I never know what formula to use. So I always start with this one formula called the sum of all the forces. So that little Greek letter sigma stands for the sum of them. And that means you got to add them all together if it's the sum of all the forces. So I'm going to add F1 to F2 to F3. But the problem is F1 is not pulling straight up in the y direction, because this is the sum of all the forces in the y direction. It's pulling diagonally. So I want to figure out how much is it pulling just straight up. And then I'm going to figure out how much is F2 pulling straight up. And if you notice, F3 is pulling straight down, Doc. So therefore, what we're going to do is we're going to add all these things up. And there was a formula that I gave you last chapter. If you want to find the opposite side, you see how these red sides are the opposite side, that the sine of the angle equals opposite over hypotenuse. So cover up the O with your hand, and you end up getting the sine times the hypotenuse. Well, if you notice, this F1 is the hypotenuse right there. So if you multiply that by the sine, I'm going to write this formula down. Here's F1, my hypotenuse. I'm going to multiply that by the sine of the angle. I'm going to add that, because it's the sum of all the forces, to F2 times the sine of its angle. And then add that to F3. That's pulling straight down. Okay, so let's go ahead and put in some numbers here for this formula. Well, since the sign is not moving, that means the sum of all the forces has to equal 0, because if there was a force on it, it would be moving somewhere. I don't know what F1 is, so I'm going to bring that down, but I do know that the angle, is the sine of 30 degrees. Notice that angle is 30 degrees. I'm going to bring down my F2. I don't know what that is, but I do know that the angle is 60 degrees. And then the F3, since it's going straight down, it's just mass times gravity, because that's the weight of the sign. So I changed F to, since F equals ma. Now let's go ahead and plug in the numbers for what they mean. Bring down my 0. I don't know what F1 is, so I'll bring that down. But the sine of 30 is 0.5, so I'm going to put that 0.5 in there. 0.5 times F1. The sine of 60 is somewhere around 0.866, so I'm going to bring that down. Put F2 down here. I'm going to put in my mass. Well, the mass over here is 10 kilograms. You can see right there. So I'll put 10 kilograms. Gravity is negative 9.8, so you put that slap mammy in there, and that fills in everything. Well, what I'm trying to do is I'm trying to eliminate one of these unknowns all by itself. So I'm going to figure out what F1 is all by itself. Well, to get F1 by itself, let's take this negative 98 to the other side by adding 98. So if I add 98 to this side, I'm going to add it over here too. And so that gives me a 98. Now I'm also going to subtract 0.866 F2 from both sides. So I'm going to subtract 0.866 times F2 from that side. So that brings all this over, and that equals 1/2 of F1. Well, now I got to get rid of the 0.5, so I'm going to divide both sides by 0.5. So a lot of this is not hard physics, it's hard algebra. But whatever you do to one number, you got to do to all the numbers on this side. So I'm going to divide the 98 by 0.5 and the 0.866 by 0.5. And so at the very, 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 very end, that tells me these cancel out, and you're left with F1 equals this great big stuff over here. Will have 98 divided by 0.5 is 196. Subtract that, and 0.866 divided by 0.5 is 1.732. Bring down my F2, and so all of this equals F1. That's going to be really, really important. But whenever you have two unknowns, you got to do what we call a system of equations. You got to put this into another equation. Well, if all this red was the x direction, y direction, let's do another one, and we'll make it green for Christmas for the x direction. So now we're going to try to figure out how much each one of these gets pulled in the x direction right along that green line there. So I come back up here. I don't know what formula to do, so I always start off with the sum of all the forces, but now we're going to do that in the x direction. Well, F3 pulls straight down, so it doesn't have any x direction whatsoever. So I'm going to say that that sum of all the forces in the x direction equals F1. But we got to remember, F1 is the hypotenuse. So if you want to find the adjacent side, which that green side is the adjacent side here, okay, we know that cosine equals adjacent over hypotenuse. Well, since F1 is my hypotenuse here, I can simply multiply that by the cosine of the angle. Oops, let's go ahead and put the angle in there. Okay. And then add that to F2, cosine of its angle. Now there's one thing I boo-booed here, and that is which way does F1 pull in the x direction? It pulls to the left. So that means this one must be negative. I think it's a little tricky there, because sometimes one little sign can make all the whole kit and caboodle go bad. So I'm going to now plug in all the numbers. Well, the sign's not moving, so the sum of all the forces has to equal 0. I don't know what F1 is, so I'm just going to bring that down. The angle is 30 degrees, so I'll put the cosine of 30. Bring down my F2, because I don't know what that is. And then the angle over here is 60 degrees. Bring that down. Let's go ahead and plug in some numbers. I'm going to shift this down. And, that's really working. Well, let's go ahead and bring down the numbers here. The cosine of 30 is negative 0.866. I got that negative from this F thing over here. That's 0.66. Brought down my F1. The cosine of 60 is 0.5. So that's 0.5 times F2. But this time, instead of solving for F1, I want to solve for F2. So here's what I'm going to do. I'm going to get everything equal and say that F2 is equal to something. But look what you can do here. I can take this red F1 up here, and I'm going to plug it in right there. So when I rewrite this whole equation, watch what happens. I'm going to bring down my 0. I'm going to bring down my negative 0.866. But for that F1, I'm going to plug in that red equation of 196 minus 1.732 F2. So all of a sudden that F1 disappeared. I'm going to bring down this 0.5 F2 here. So again, these problems get really, really long just because of all the algebra. Now let me go ahead and multiply all this apart. Well, if I take the negative 0.866 and multiply it by 196, I get a negative 170. A negative times a negative gives you a positive, and 0.866 times 1.7 gives you 1.5. Now guys, I'm rounding up, so when you do these on your calculators, you might be getting a little teeny bit different answers, but it's pretty damn close. And then I'm going to bring down my 0.5 F2 from the top there. Let's combine all those like terms. And so now I'm going to bring the 170 over here to the other side. So that gives you a 170 equals 2, because 1.5 plus 0.5 is 2, F2. And if you divide both sides by 2, now F2 ends up equaling 85 newtons. So all that work just to find out what one cable had a tension on. Well, what's really sweet now is you can take this answer and plug it right back into that one. So let's do that here. I want to figure out what F1 is now. I'm going to bring this equation over. So F1 equals 196 minus 1.732 times F2, and we just said that F2 is 85 newtons. That's really staying on there. So when you do the math here, F1 now ends up equaling 48.78 newtons. So now we found the tension on F1. That's the second answer. And you say, well, now I got to figure out what the tension is on F3. Actually, that's really, really easy because it's the weight of the sign. So all we have to do now is find for number 3. F3 equals the weighted sign, so it's mass times gravity. So the mass is 10, gravity is negative 9.8, and so that gives you a force on number 3 of 98 newtons. So actually it's negative 98 newtons because it pulls down. Now once again, I said that the sum of all the forces have to equal 0. Well, here's what's really, really cool. If you take the F3 of negative 98 and you add that to a positive 85, and then you add that to a positive 48, you end up getting absolute 0. That's all we have to say about that. Actually, hold on here. You can't just add those numbers together. You got to take that and put it in this equation here. So if you go back up to the original equation, this one right here, and you put those numbers in for F1 and F2, then you will end up getting 0. So that's how you can check yourself. So, yep, that's all number 1. And so 12 minutes later, we get the answer. We're going to go on now to number 2, and that'll be on a different video. So just hang in there with it all. Love you. Bye.